G'day, g'day, comrade subscribers. Remember this fellow, the Alpha BK? I've only made one video on it because, well, it doesn't work, and I didn't have any because it's an 8080 based machine. Well, clone of the 8080. It's actually, I believe, the so there's a homebrew computer called the Radio 86 RK. And using the 8080, and I think this is kind of a not a professional, but well, it's rather than make the computer yourself, you could maybe get an Alpha BK. So it's basically a Radio 86 from what I understand. But yeah, so when I got this was my first 8080 based machine, really, and so yeah, I had no idea where to start. So let me just get this heavy. It's quite an interesting machine. It's got an SMP59 connector there for the keyboard and interface. So let's see, what can I disconnect? Okay, I can't disconnect the power. That's all on there. Actually, it looks like. So this is an SMP59, is it? 64 way, so it's a 2x32 connector there for the external interface and keyboard. See, we've got TV output there, magnetophone, MF, yeah. So wasn't working when I first tried it. Well, I wasn't getting a video output signal, put it that way. But I think it's been a while. I thought maybe I'd give it another try. So the only thing that's really socketed is this ROM. It's got two ROMs. So if this is a Radio 86 machine, then it's got basically a firmware ROM and it's got a character ROM. So one of them's a 2K character ROM, the other one is the 2K monitor or something like that. Actually, I'll show you this other one I've got. So I'm just trying to figure out where to put that. So this is a modern recreation of it by Sergey, good old Sergey Kiselev, quite a prolific fellow. Yeah, so this is one of the machines he's made. So yeah, modern recreation of the Radio 86, but yeah, I've not finished it yet because again it's got a 2K monitor ROM and 2K firmware ROM, which I can't use in my window. I haven't been able to burn those 2K ROMs yet, so work in progress for a long time. But basically, yeah, that's what this is. So really, I could probably desolder these if I really wanted to and stick them onto here. And as you can see, I did start. It was rather laborious because obviously it's a Soviet Cyrillic keyboard. So I did start printing labels. So yeah. Anyway, work in progress. So back to this machine. So it's an 8080. So this rather beautiful power supply here should be outputting plus minus 5 volts. And 12 volts. So I guess that's one thing I didn't check. So we do have a regulator up there, and we do have a rectifier there, I guess. And I guess the power goes out this way to the keyboard by the looks of it. So there's some going to the keyboard and then some more looping back around here, all going into this main interface here. So I'll give it another. I'll give it another boot, just see what it does. Well, actually, let's have a close-up look first, because I haven't actually pulled this out, as you can see, because everything's kind of. I haven't even replaced the regulator. Let's have a closer look. So it's quite a nice. I think it's well, it's a very solid machine. Yeah, a lot of effort's gone into. I think a lot of effort's gone into it, because you can see we've got the the good old shibari, Japanese rope bondage, used for keeping all the connectors together. So, oh yeah, so it's a nice case, let down by the keyboard. We've got the nice capacitors here that usually get chopped off and sold for scrap, thus rendering a lot of these computers useless unless you replace them. So it's good to see these are all in place. I guess that's one thing to worry about if you're going to buy one of these, is make sure the capacitors are all still there. It's not a big deal. As you can see, we've just got decoupling capacitors here. Just put new ones in, but it's a pain. So what have we got? We've got a nice big transformer that contributes to most of the weight coming in. So actually, you could actually replace that. Let's have a look. So because it's an 8080, it's got 3 voltages. It's got plus 5 volts. I think this is ground, and we've got minus 5 volts and plus 12 volts coming out of the power supply. So we've got the transformer output coming down here, obviously diodes here. So this is where rectification occurs. Smoothing capacitor here, nice big one, 5,000 microfarads, so good size. So one linear regulator. So this is a 7805 equivalent, I think, KT805AM. So you can see actually that you do have space, like the traditional, is it a TO220 case? So, but obviously they've attached to the case here as a massive heatsink, but I might replace that with a modern switching version that just goes in there nicely. Obviously the power cables can't be removed. So basically we've got the connection here, we've got power going up to the top case here, and then to the keyboard, and then attached all to here, going to this connector here. So we could unscrew the board and pull the board out. The connector will still be connected there, but we've still got this power connected here. So I might see if I can change this somehow so they can be disconnected. So that's the power supply. I think we've had a look. Yeah, had a look at the keyboard connectors there. So here we've got a Soviet. It's an SMP 58-64. So it's a 2x32 connector, pretty much identical to a DIN 414612. Have I got the numbers around the right way? Pretty much identical, except it's Soviet 2.5mm pitch, not Western 2.54. So you could buy a DIN connector, but I think for something like this that's 32, it'll just won't fit. The DIN connector will be too wide by a couple of millimeters. Smaller one you could probably force, but after 32 pins, you got this 0.04 of a millimeter, which isn't much, but it adds up. So if you want to get, especially here, if you want to get something to connect to it, you need to basically get the Soviet. So you can buy them, for example, in Ukraine. If you know people in Ukraine, then they can help you get them. That's the only way I've got them, actually, is because companies in Ukraine won't ship overseas at the moment for certain reasons, obviously. So that's the connector there, bringing power and everything. So the board itself, okay, this is the heart of it. Obviously, this is an 8080, so this is the Soviet version, a KR580VM80A. So that's the 8080A CPU. Beside it, this is a KR580VT57. So this is equivalent to a Intel 8257, which I think is a DMA controller. And then over here we've got a Soviet chip. What is it? A K589? Is it? Hang on, sorry. K589 IR12, is it maybe? So I'm not sure what that is. Might be some specialized type of ROM or something. We've got two 2K ROMs. I think one of them is the actual firmware monitor, and the other one is the character ROM. I'm not sure which is which though. So this one, maybe this is the monitor here, and that's the character ROM, because, well, you don't need to usually replace the character ROM. Here we've got a KR580VG75. So this is an 8275, an Intel 8275, which is a CRT controller. So that might be interesting to look at, because at the moment we get no output whatsoever, not even a black screen or a flickering screen. We get nothing. So might be interesting to check that one. Another Soviet chip here, not sure what that is, a K155IR13. Don't know what that does, have to look it up. But here we've got a pair of, so this is a KR58 580VV55A. So these are 8255. So these are pretty ubiquitous, like the 8255s are. Programmable peripheral interface. So yeah, interface adapters. So you probably have one for the keyboard and one for the interface there. What else? I guess maybe this might be an op amp or something. Maybe this is for the cassette input output, perhaps. So maybe an op amp or something there, I think. I don't know. We've got some general logic down here, and okay, where all these nice decoupling caps are. This is the RAM, or the DRAM. So it's a KR565RU5D. So I think generally these are 64 kilobit. So there's 8, which would mean 64 kilobytes, but I believe the Alpha BK only has 32K, so these might only be 32 kilobit. I'm not sure. Yeah, and then just some other general logic. It's hard to tell with these Soviet chips what logic they are, because, you know, K155, what's that, LP5. I don't know what the equivalent 74LS is. So there we go. So that's basically the machine. It's pretty simple, it's nicely laid out, but it just doesn't work. So I don't know where to start really. I guess logic analyzer. I think I have checked the voltages. Voltages are okay. And I think I have checked them on the 8080, and they were okay on the 8080. So I don't know, maybe look at the CRT controller. Yeah, try and figure something out. Let's see. Powered it on. So you can see power is on, and also the Rus is activated. So on these keyboards, you've got a Rus and a Latin, so you can switch between Cyrillic and Latin characters. But pressing the nice responsive doesn't do anything there. So I'm assuming the machine's not working, and there's no video output coming at all, not even a black screen. So let's well, I don't know, let's tinker around, and there's a nice, you can feel a hum coming from the transformer. So let's say nice metal case that's not earthed. Okay, awesome. Alright, so let's start doing something. So like I said, I could replace this 5-volt regulator. The pin out looks pretty good, so I can just plug something straight in there. Would be good to, I really wish I could just separate the board, take the board out and troubleshoot that separately, rather than having all this bloody keyboard connected to it. So what I might do first is, I've got these from Element 14. So these I got for the BBC Model B. These pretty much are the little power connectors on the BBC Model B board. So I've got those. So I might, if I can, really need to move the way this camera, maybe can I do that at an angle? Zoom out, there we go, maybe zoom out. So I could maybe stick those in on the power board, and then on the wires I have some connectors like so. So then I could connect them in like that. That way I can disconnect this at least. Although that, okay, that's the on-off switch. Okay, I think this is the wiring for the on-off switch. Up there as well. So that's all part of this shibari. I really don't want to cut this open, but it might be better to cut it open so that I can work a bit better with it. All right, let me do some work on the power board first, and go from there. So I got most of it out. So obviously still connected to the transformer. I'll get rid of these first, I think, so they can be unplugged. Obviously I'll need to mark them so I know what's what. Yes, obviously this whole thing I could just replace with a Meanwell power supply very easily. That would fit in quite nicely in here, actually, a modern one. But this seems to be working, so let's keep it. Yeah. Do a quick before and after. So that's what one of them looks like at the moment. So that was obviously the insulation there. I don't know what this purple stuff is. It's some sort of insulation as well. But I will replace that with that, and then hopefully it should just plug in. There we go. So I'm just going to try and color code them as well, so different colored heat shrink, like so. So hopefully, I think that's plus 5 volts. I think that's plus 5 volts. That's ground, and then minus 5 and plus 12 or something like that. Okay, so I just had to drill the hole a little bit bigger so that would fit in, but should be okay as I do this one-handed. Blurry, I know. I'm trying to do this one-handed. But you know what I'm going to do. So yeah, oh there we go. Okay, so that fits in there now. Lots of solder on that side. And then I'll be able to disconnect it. And actually what I might do, because these are actually numbered, so I might actually I do have the schematic, so I should be able to confirm from the schematic. I think there is a power one. Yeah, anyway, so that's what I'm doing, so you can see what I'm doing. I'll finish off the rest. So far so good. Plus 5 ground, plus 12. And now that I get to the last one, the minus 5 volts, I can actually see they did have a post in there. But it's not one that I can really use. Oh, maybe I could slide onto that one. I'll give it a try, otherwise I'll just replace it. There we go. At least I know what's what now. Minus 5, plus 12, ground, plus 5. And I can detach them. So at least this part can be detached, apart from here, which is I think the power switch. Yeah, so I might have to cut some of this shibari, and yeah. Anyway, getting there. So I'll do this next, and well, I would say make sure it still works, but it doesn't work. So yeah, so that's all free now. So it's just these two here. So they go off via this shibari to the on-off switch. On-off switch. So power in, on-off switch, and then other side goes via the fuse, and then these two come off to the transformer input. So I might do a similar thing. I might just take these off and then put a little tab on that we can slide on. I think that might be the best way to do it. And then this whole side is disconnected. Then it's just this side here, which I'm assuming I just need to undo these screws, and then the board will pull out. I still need to power the board though, but I could do that separately, maybe. So yeah, there we go. Got those there. Got these here, so I just need to hook them back on. So that's that side done. Now I should be able to pull the board out and figure out how I'm going to power it. So 2 screws are undone, so I think it should just, there we go. Alright, board is out. Now 2. Alright, might as well keep those there. So it's a pretty nicely made case. You know, we've got screw holes here and standoffs and stuff like that. So yeah, that screws into there. No need for a nut underneath. Yeah, alright, so as I said, so I'm not getting any CRT, any video output at all, so I might wire up another video cable. So I keep saying composite, but it's obviously not composite, it's black and white. So it's just baseband video. Signal. Yeah, so that can all go back together. I'll use a separate power supply, I think. My Meanwell. So I've just got the board itself now. I've just about got it ready to, well, to power it on again, but not for video. So I'm using this good old Meanwell power supply, quite handy. As you can see, model GP25A13A-R1B. So it's got plus minus 5 volts and 12 volts coming out to a DIN. I've got the DIN there. I've made up a little connector, socket there to a 4-pin header here, and then I've soldered on a header here, managed to make it fit on, and then I've just run some wires to the various power rails. So I should be able to power it like that. So I've got 4 little header pins free. So next thing will be to get the video. We'll try and find the video output. So there is on the schematic, I think I saw it there, it is, what there, video, B13. I'm not sure exactly what these numbers are because they kind of overlap. But B13, A13, B13. So B13 looks like video. I'll unplug that. So which way is that counting? Is there anything under here? Oh, okay, we got 32 over here. And does that mean that's A1? Does that mean A1? So does that mean B13? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So maybe this one here over to here, so maybe that's the video output. Maybe that's the video output there. So I can hook up an RCA cable to that, and again just see if I'm getting video output, and then maybe do some testing from there. Oh, getting there. Maybe I'll start testing in the next video. Have a break from all this, getting it ready to test, and then actually testing. So yeah, in other words, putting off the hard work. Very simple test you can do, which has actually solved a problem on another Soviet machine, Electronica MS511, is just check for hot spots. So I can feel the 8080 is hot. So let me just try on here. Oh. Okay, let me start now. Record video. Yes. Alright, just so I can sync it. Alright. So, yeah, you can see the 8080 is getting pretty warm. Whoa, that one's hot. That one is, yeah. Okay, the ROM is, nothing's happening with the ROM. So this one here is getting really hot. It doesn't look it. It doesn't feel it. Little op amp. So that's the 8255s up there. That's the 8-bit shift register. Coming down here, that's the DMA controller, 8257 was it? Yep, 8257. Doesn't feel warm, but obviously it's slightly higher than ambient. There's the 8080. Yeah, it's pretty warm to the touch. Then there's that strange chip. Then the ROM, which you can't even see. It's cold, so yeah, definitely not operating. We come down here. This one is, well, it says looks like it's quite warm. Which one's that one? What's that one there? All right, I'll have a. It doesn't feel warm actually. It doesn't feel warm at all. It's just warmer than ambient, I guess. Yeah, nothing on the RAM. So yeah, it's pretty dead, I would say. I would have thought the RAM would be a lot warmer if it was operating. So I can't. It doesn't feel hot, that one. I can't really feel anything on those ones. They're just slightly higher than ambient, obviously. But the 8080 is the hottest. So the fact that the DRAM and the ROM have nothing at all makes me kind of think that just maybe the 8080's dead. It's not doing anything, because I would have thought that the ROM would be getting warm as well as the RAM. So maybe I need to try and get this one out and socket it and put a replacement in, perhaps a nice Polish one, perhaps. Yeah. All right. Well, let me stop recording. Right, so I reckon I've had a look. I just noticed two small things. I don't know if you can see it. Well, first one is on the 8224, the clock generator. So that's pin 1, which is the reset output. Looks like the track's been broken, but then has been resoldered. So I don't know what that's about. So yeah, the 8224, they also use it in the IBM PC. So I remember fiddling around with that. Anyway, so let me figure. I'm going to try and put the loop on. You can see it, but pin 4 of the CRT controller, just near that. I'm not too happy. There's a bit of a hole. Just trying to focus on it. Yeah, I'm just going to reflow the solder. I know it's not going to make any difference, but it doesn't look perfect. But yeah, so I guess looking at the 8224 or the 8224 equivalent. So here's the pin outs. Pretty simple. So we've got the clock 1 and 2 for the 8080, and we've got the oscillator output. So oscillator output here is just crystal oscillator output. So these are the clock outputs to the 8080. It's clock 2 TTL level apparently, and then we've got reset out, reset in, ready out, sync, ground. I think it's plus 5 volts and plus 12 volts. So we can have a look at that, see if this is actually working and providing a clock to the 8080. If it's as simple as that, hopefully. As you can see, we've got a capacitor here as well, and the crystal. So I do have replacement 8224 originals, so I can always replace that. So I'll try and hook everything up and see how we go. All right, let's try this. I don't know how to record. I don't know if I can record the actual trace on my oscilloscope. It's the Siglent SDS1304 CFL. I don't know if I can record it, so I'm just going to film it. Anyway, so the board's powered. So I'm going to check clock 1 and 2 output on the 8224. So that's pins 11 and 10 respectively. So that's pin 8, that's pin 9, pin 10. So this is clock 1. So, okay, there is some output. What does it reckon? It's not really stable, is it? It's about 50, 60 kilohertz. It's going all over. It's not really stable, is it? Well, it's not really giving me an accurate frequency. The frequency is going up. All right, so that's clock 1. Whoops, this is clock 2, which is pin 10. Okay, so we're getting output. That looks all right, doesn't it? Okay, so now if we go to the 8080 and we look at, let's say, clock 2 input, which is pin 15, 20, 19, 18, 17, 16, 15. Okay, so that looks more, yeah, so 1.77 megahertz. I think that's about the frequency this thing runs at. All right, so there is a clock 2 input. What about, is there a clock 1? Clock 1's on the other side, pin 22. I don't know if it needs both. Pin 21, pin 22. It's about the same, 1.77. Okay, so we've got clock. Okay, clock's working. It is very hot. It is very hot compared to the other chips. And there's absolutely no heat on the EEPROMs. So I know Western EEPROMs of this same vintage and RAM, they do get hot. So Soviet one's not getting hot at all. Kind of tells me they're not being used. The 8080 is getting hot. So, okay, sync, pin 10. I don't know if we're going to see much on here. Pin 10. Oh, pin 19, sorry. That's a sync. Okay. Is it supposed to be TTL level? Because that's not TTL. Reset, hold. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's reset. Not really expecting much on there, I guess. Hold. Interrupt pin 14 or int. What about an address pin A10? So okay, so there is activity. All right, so there is so there is activity. So that's A10. All right, so okay, so that's D4, D5, D6. You getting anything on D6? All right, okay, there is some. That's D6, D7. D7, D3, what about D3? Not seeing anything at all on D3. All right, okay, no, I just didn't have it pushed down hard enough, okay. D3, D2. All right, D2, D1. Okay, D0. So should these be, because this isn't, oh no, I do have the 10 times on, don't I? I do have the 10 times on. Apparently they're getting rid of those probes with 10 times because people forget it's turned on. All right, so that is kind of TTL, I guess. Looks like about TTL. What was I up to? D0. So reset, hold, interrupt, dbin, ready, wait. I'm going to address. Alright, so I might have to do something else. If there is actually address activity, but how come the ROM and the RAM aren't getting hot then? Let's hold A. Okay, that's clock 1. That's ready. So is ready active high or is it active low? Go the other way. Don't know. Doesn't seem to be much activity unless it's active high. Oh, I'm going the wrong way, aren't I? Alright, that's ready. Was it 21? 22. 22 was the clock again. 22, 23 was ready. 24 was wait. 25 is A0. Whoops. A0, so there's activity there. A0, A1. Okay, it's plus, that should be plus 12 volts there. So, okay, so I'll just go backwards. So this A11. So there is, it looks like there is activity. Okay. So I guess the next thing to check is, because we're not getting any CRT output then, is check the CRT controller. It does look like we've got activity on all the address pins. All right. Stop that. Okay, because it's been running for a few minutes now, the DMA controller is starting to warm up as well. CRT controller here. So I might check, might add video output there next. Because that's the first thing, is there's no video output. Right, now that we have established that the CPU does indeed seem to be working, so let's have a look at the video output. So on the expansion connector here, it is B13, which, so I don't know why this is offset, but I think it is basically signal 25. So if we zoom in on the 8275 CRT controller, we can see here it is actually connected to the character ROM, which is D9, which is this one up here. So I was right. This is the character ROM and this is the monitor software, the firmware. So, oh yeah, you can see the lines here. So, yeah, character ROM there. So some gunk there. Okay, so CRT controller, character ROM, some other bits and pieces. But basically we've got HRTC, VRTC, so is it vertical retrace, horizontal retrace? I've got the data sheet here somewhere. Programmable CRT controller. HRTC, VRTC. What do they actually stand for? Horizontal retrace, vertical retrace. So, output signal which is active during the programmed horizontal retrace interval. During this period, the VSP output is high and the L10 output is low. Okie dokie. All right. So, we've got horizontal retrace, vertical retrace output coming into here. So I guess maybe that's an OR gate or something, I don't know. It's D7, wherever D7 is. Anyway, comes down here, along here, up to here. We've got a transistor, maybe a buffer or something, I'm not sure. But down here, capacitor, and then up to signal 25. So it does look like I was correct. B13 coming up somewhere here, coming to, so we've got an electrolytic, so which is C5, which is that one there actually. So that's the electrolytic, and I think that was the other one, something like that. Which way was it? B13. So I think it was one of these, wasn't it? Across to here, connected to that, and then connected to that. Yep, all right. Yep. So it's yeah, these two capacitors here, electrolytic and well, I wouldn't say ceramic, a beautiful green Soviet one. And I guess that's the transistor. It's got 3 legs. Okay, V2, that yellow thing, that's the transistor. What is the transistor? The transistor is a KT315B, okay, whatever that is. All right, so I'll hook up a wire there, and similar, let's just see if there's any sort of video output, because I was getting nothing. I wasn't getting, it wasn't a black screen, it wasn't a rolling screen, it wasn't a intermittent screen, it was just nothing at all. So I guess what I want is the, yeah, I guess the other side of this capacitor. So yeah, probably just hooking a wire somewhere along this trace here. All right, and then I think I might call it a night. This I try to keep my videos not too long, because you know, I'll make a 1 hour video, and then the average watch time is 3 minutes. So yeah, I try to not keep them too long. I try to keep them small and manageable. Anyway, so yeah, I'll hook something up there and see what we get. All right, let's. It's powered on, it's running, and let's see what's coming out on this. Okay, so we're getting something. Should it be negative like that? I thought it was. Is it inverted maybe? I don't know off the top of my head what it's supposed to look like. So that's 1 volt. So it looks right. So yeah, I don't know what a. It's kind of looking right, isn't it? Set the trigger one way. So maybe we are getting video signal output, but what I've got couldn't see it. Okay, well what I do have is I've got an RCA cable with alligator clips on it, so that I can very quickly, I think I do, very quickly hook it in to see what sort of signal I'm getting. If I can find it. I don't want to have to make another one. Here it is. I think this is the one. What's that connected to? That is connected to an RCA plug. Okay. Let's zoom out. So what I'll do is we zoom down here. That's my video output signal, so I'll just hook it up to an RCA cable and just see if I can get something like that. Right, hooked up, power on, and yeah, so doesn't like it, whatever it is. Not getting anything. Power off. Okay, so it is getting the signal, but the LCD doesn't like it, because that no signal goes away. Can't even display a black screen. Okay, so yeah, all right. So whatever it's outputting, my LCD doesn't like. So I might have to do some research as to what it's outputting. Okay, well, I think we'll call it a night there. Research to be done, and so maybe it is working. I just need to figure out what it's outputting. Okay. Of course, if you know what it is, please do let me know. Bye for now.